So the question here is, consider the op-amp based circuit shown in the figure full stop. Ignore the conduction drops of diodes D1 and D2 full stop. All the components are ideal and the breakdown voltage of the zener is 5 volt full stop. Which of the following statements is true? Question mark. Option A. The maximum and minimum values of the output voltage V0 are plus 15 volt and minus 10 volt respectively. Option B. The maximum and minimum values of the output voltage V0 are plus 5 volt and minus 15 volt respectively. Option C. The maximum and minimum values of the output voltage V0 are plus 10 volt and minus 5 volt respectively. Option D. The maximum and minimum values of the output voltage V0 are plus 5 volt and 10 volt respectively. And this is the question they had asked in GATE 2023 for electrical from the subject of analog based on this op-amp topic. So if you'll see that as per the observation of this circuit, here this input is given V in is equal to 10 sine 1000 t volt. So this is having the wave shape like this. So this is the input voltage with respect to time. So this is having plus 10 volt here. Their maximum magnitude is plus 10 volt and their minimum magnitude is minus 10 volt. And it has mentioned that all the components are ideal. It means it is saying that this op-amp is also ideal. And for the ideal op-amp, this virtual ground concept is applicable. So if this is having ground here as a 0 volt, then this node will be also as a 0 volt. And as we know that diodes are unidirectional. So it means if D1 diode is conducting, it means current has to flow in this direction. What I can say it here as a I1. And if this D2 diode has to conduct along with this zener diode, then their polarity will be like this. This side it will be plus, this will be minus, this is plus, this is minus, and current will be flowing as a I2 in this direction. For this D1 diode, their voltage polarity will be somewhat like this, plus and minus here. And it has given all the components are ideal. It means it is saying that this diode will be short circuited under the forward bias and this D2 diode will be short circuited under the forward bias, and both the diode D1 and D2 under the reverse bias, this will be open circuited. So that is the ideality of this device. And as a zener diode, if it is conducting, it means this will have the zener breakdown voltage of 5 volt. So now based on this input as a V in is equal to 10 sine 1000 t volt, we need to find out their output voltage, their maximum value and their minimum value. So first of all we need to consider their positive half cycle, and later stage we will consider their negative half cycle. So as per the virtual ground concept, this is here 0. This inverting node potential is 0 volt. So whenever this V in is positive, it means current is flowing in this direction. So here if it is flowing in this direction, it means this current will follow the path of D1, and this is not going through this D2 or this zener diode, because if these two diodes are conducting D2 and DZ, then current should flow as like I2, and here this is not allowing in this circuit. So for the positive half cycle, as per this node potential is 0 volt, that current will be directing in this way, whatever I had shown here. So we can say that there for the positive half cycle, D1 is on and D2 and DZ not conducting. So here their maximum value of this input will be what? Their input maximum value, it will be 10 volt. So this is their maximum value in the positive half cycle. So whenever it is having maximum positive value, by that time it is allowing the maximum current passing through this path. So here In that way, we can apply the KCL at this inverting terminal of this op amp, and we can write it here as a V in max minus 0 divided by 1 kilo ohm. So let's say this as a I3. So this I3 is equal to I1. So V in max minus 0 divided by 1K is equal to 0 minus V out divided by 1K. So this 1K gets cancelled, and we got it here as a V output is equal to minus of V in max. So here V in maximum value is 10 volt. So this output will become here as a minus 10 volt, because this positive half cycle positive input is given to the inverting terminal of this op amp. So that is the reason it will produce their inverted output as a minus 10 volt. So one parameter we got it here. For the positive half cycle, if the input maximum value is 10 volt, then their output will have minus 10 volt. Now we need to discuss about the same circuit for the negative half cycle. So what will happen in this negative half cycle? For negative half cycle, that whenever this is having negative values as an input and their inverting terminal is at 0 volt, it means current always flows from higher potential to lower potential. So in this situation, current will be passing from 0 volt towards this source and then through this ground. So in that negative half cycle, what will happen? In this direction, to meet this direction, current will not pass through this D1, current must have to pass through this D2 and DZ. So this D2 will be acting here as a short circuited. By that time, there is no voltage drop of this, only there will be voltage drop across this Zener diode. So here it is having the voltage drop of Zener volt as a 5 volt. So at this point, it is measuring here as a minus plus 5 volt, and this is a 0. So with respect to 0, if you will measure whenever this input is given as a negative half cycle, by that time this D2 and DZ is in the conducting state. This I2 current is flowing through this, and the same current is passing through this 1 kilo ohm in this direction, and we can easily find out their current also. So how it will be? The current will be I2 is equal to 0 minus of V in divided by 1K. So by that way we can easily find out, and this V in is negative in negative half cycle. So by that way we can find out their I2 value, but here our interest is to find out their output voltage. So this output voltage, as we know that this inverting terminal is at 0 volt, so this input voltage drop across this 1 kilo, whatever is the voltage supplied through this V in, this entire voltage will be taken drop across this 1 kilo ohm. So this output voltage will appear with respect to 0 volt, it is having 5 volt here. So we will get it here, V output is equal to plus 5 volt, which is nothing but Zener diode cut-in voltage, whatever it has given breakdown voltage. Zener diode breakdown voltage will be their output voltage in negative half cycle, because as we know that this is the inverting op amp configuration. So that is the reason if the input is negative, output will be positive, and here in this case input is positive, so output we got it here as a negative. So now if you'll see that their maximum and minimum values, then this is giving here as a maximum values. So this V output maximum, it will become here as a plus 5 volt, and V output, this will behave here as a V output minimum, because comparing these two values of the output, one value is coming as a plus 5 volt which came under this negative half cycle, and the another value in the positive half cycle we got it V output as a minus 10 volt. So plus 5 volt is larger compared to minus 10 volt, so their maximum value of the output will be plus 5 volt and their minimum value will be minus 10 volt. So these two values is matching in option D. So option D is the right answer for this question, and by this way, this is the end of the explanation for this question. So the question here is, all the elements in the circuit shown in the following figure are ideal full stop. Which of the following statements is or are true question mark? Option A. When switch S is on, both D1 and D2 conducts and D3 is reverse biased. Option B. When switch S is on, D1 conducts and both D2 and D3 are reverse biased. Option C. When switch S is off, D1 is reverse bias and both D2 and D3 conduct. Option D. When switch S is off, D1 conducts, D2 is reverse biased and D3 conducts. And this is the question they had asked in GATE 2023 for electrical as a MSQ of the question. And basically this is the question based on the multi-diode circuit. So here we need to find out the status of the diode in two situations, when this switch S is closed and when this switch is open. And here it has mentioned that devices are ideal. It means they are telling that this diode is ideal. So whenever diode is conducting, it will behave here as a short circuit, and whenever diode is not conducting, then it will behave here as a open circuit. So by using that concept, we need to solve this multi-diode of the circuit, and we need to find out the status of D1, D2, D3 diode. So first of all, in the first case, we'll consider that switch S is open, and then we will see that the status of the diodes. So in this case, we are assuming that this switch S is open. It means this part of the circuit will work here as a open circuited. This part will work here as a open circuited because switch is open. And here in this part, rest of the part we need to analyze. So now we need to check the status of the diodes as a D1, D2, D3. So we had assigned 3 node point as a node A at this place. This is node B and this is here as a node C. So now if we will apply the KCL at this point, for example, let's say at this node point A, so if this is D1 diode current passing through this, if it is conducting, I am saying that this is I1, and current passing through this D2 diode, I am assuming this as a I2 if it is conducting. If it is not conducting, then that condition, this will be 0. So here if we apply that KCL at node point A, then what will be the equation here? At this point the incoming current is 4 ampere. So here we can say that apply KCL at node A. Then we'll get it here as a I1 plus I2 is equal to 4 ampere. Let's say this as a equation number 1. At this point, whatever is the incoming current is 4 ampere at this point, and outgoing current is I1 and I2. So here this will be I1 plus I2 is equal to 4 ampere. Let's say this as a question number 1. Now in the similar fashion, we can apply here that KCL at node point C. So at node C, apply KCL, then we'll get it here. At this point, the incoming current is 2 ampere and another one is I1 here, and outgoing current we can assume this as a I3. So we can write it here. This I3 is equal to 2 ampere plus I1. 2 ampere plus I1. So let's say this as a equation number 2. Now here we don't know about that whether this I1 is positive. This I1, if the diode is conducting, I1 will be positive. If diode is not conducting, this I1 will be 0. It means this will behave here as an open circuit. In the similar fashion for this D2 diode also, if D2 diode conducts, then this I2 will be positive. Otherwise, this I2 will be 0. So what it is saying that this I1 and I2 both cannot be 0 at a time, because the right hand side is 4 ampere. So to justify this equation, this I1 and I2 cannot be 0 at the same time. This indicates that D1 and D2 diode both cannot be off at the same time. Both cannot be reverse bias at the same time. And from this equation number 2, this is giving here I3 is equal to 2 ampere plus I1. So I1 is having the possibility this will be either 0 ampere or positive value. So if it is 0 ampere or positive value, irrespective of this I1 value, because I1 cannot be negative, so this I1 will be either 0 ampere or positive value. It means I3 will be always positive. So I3 is the current passing through this D3 diode, and this is indicating that irrespective of this I1, if switch S is open, this D3 is always conducting, or we can say that forward bias. So this is in the conducting state. We got the status of D3. Now from the first equation we need to check it which diode is in the conducting state. As I had explained, this I1 plus I2 is equal to 4 ampere. It means this cannot be negative, so, and even both cannot be 0 at the same time. It means that I1 or I2, this D1 and D2 cannot be off together. So it means what it is giving the idea that D1 and D2 cannot be off at the same time. It means it is giving the another idea that this either D1 will be on and D2 will be off, or D1 will be off, D2 will be on, and there might have the chances that both may be on. So here we need to find out the status of this D1 and D2 now. So in this case, if I am assuming that D1 is on, so if I am assuming that, here we need to make the assumption D1 and D2 both is on, then what will happen? If D1 is on, it means this will behave here as a short circuit, and what will happen? This D3 is already in the conducting state, and ideally this will behave here as a short circuited. It means the voltage 40 volt will appear at this node point C, and if D1 is conducting, then this 40 volt will appear at this node point A also. And if D2 is conducting, then this will be short circuited, and at the same point this 20 volts would appear. So as per the KCL and KVL rule, we can say that at one node point, two different voltage is not possible. At one common node point, this 20 volt and 40 volt is not possible. So this is saying that this violates KCL rule. So it indicates that so D1 and D2 cannot be on together. Now we have the another two possibility. What is that? We have that we can assume either D1 off and D2 on. Then we have to check it about the condition. So let's say in this case I am assuming that D1 is on and D2 is off. Then how it will behave here? If D1 I am assuming that this is on, if this is on, so at node point C voltage is 40 volt, and that will appear if D1 is on, then at this point node A, this will appear here as a 40 volt. And if you see that this is the current source, so current always flows from higher potential to lower potential, and as per the direction of this current source, if node A is having 40 volt and this side it is 10 volt, it is not allowing for the flow of this 4 ampere of this current source. So this is indicating that assumption is becoming wrong. So whatever we had assumed, it is not possible. It is not possible because of KCL violates. So now the next possibility is we need to assume here as a D1 off and D2 on. D2 on, D1 off and D2 on. So in this case, what will happen? If we are assuming that D1 is on, it may D1 is off, it means this C node potential 40 volt will not appear at this node point A. And now we can assume that for this D2 on, so for this D2, this must be on, because the reason is whatever it is coming 4 ampere, if D1 is off, it indicates that I1 is 0. I1 is 0. So this D2 must be on, because this 4 ampere where have to pass. If this path is not allowing, it means this must have to pass through this D2 of the diode to obey this equation number 1. So here in this case I1 is 0, it means I2 will be 4 ampere, and this is saying that D2 must be on. So what it is concluding here for this case? For this case it is giving here the idea is D3 will be on and D1 is off. This D1 will be off. D2 we got it here as a on or conducting, and D3 already we got here. In this case D3 is on or conducting. So whenever this switch S is open, we got D1 diode will be off, D2 will be on and D3 will be on. This is your short for this case first. Now we have to look it for case 2, when this switch is short circuited, or what we can say that when switch is closed. When this switch is closed or switch is on, by that time this point will show it here as a short circuited, and as per their common ground, this node potential, whatever we can say it here as a C node potential, this will be appearing here as a 0 volt. So I can say that this C node potential VC is equal to 0 volt. And for this D3 diode, their anode side voltage is 0 and their cathode side is connected through this 40 volt. So this is indicating that this D3 diode must have to be reverse bias. This will not conduct, because their anode side voltage here at this point it is 0 and their cathode side is 40 volts. So this D3 must be reverse bias. So we can write it here as a D3 is reverse bias. D3 is a reverse bias irrespective of D1 and D2. Now we have to think for what? We need to think for this D1 and D2. So there might have the chances that both, what are the possibilities now? D1, D2 will be, both will be on, both will be off, one will be on, another one will be off. Now if we are assuming that D1 and D2 is on, we need to make this assumption D1 and D2 is on. So if D1 and D2 both we are assuming that on, it means if this node C point is 0, it means at this node point this will be appearing here as a 0. At node point A, this will appear here as a 0, because we are assuming that D1 and D2 both is conducting. So if this node point A is 0, and for this D2 diode, their anode side voltage is 0 and their cathode side voltage is connecting through this B node to this 20 volt. So this is indicating that this D2 cannot be on in this situation if we are assuming that D1 is on. So if D1 is on, then D2 must be off. Then this D2 must be off. And this is one of the possibilities here. This is not possible. So both cannot be on. In this case, we had learned about this. It means it is indicating that D1 will be on and D2 will be off. Now, the next chances is, if we are assuming that this D1 is off, assume D1 is off and D2 is on, whether it is possible or not, we need to check it. So whenever we are assuming that D1 is off, it means this 0 volt, whatever it is having at node potential C, will not appear at this node point A, because it is treating here as a open circuited. So now for this D2 diode, whether it will conduct or not, so this D2 diode is conducting through this 10 volt of this voltage source for the anode side of this D2 diode, and their cathode side is at 20 volt. So here anode side voltage is lesser than their cathode side voltage. So due to that reason, this is also not possible. In this case, if we are assuming D1 is off, then in that case D2 is not on. D2 is not on here. So this is also not possible. This is also not possible here. So this is indicating what? Only the possible is having this, both cannot be off at the same time, because if both will be off, then where this 4 ampere of the current will goes. So due to that reason, both cannot be off at the same time, and other possibilities already I had explained. So here in this case, we are getting that this D1 diode will be in the on state. This D1 will be in the on state. D2 will be in the off state or not conducting state. At the same time, this D3 will be also in the off state. So this is the possible answer. This is the possible status of the diodes. We got it here. Now we need to match this with the option. So in the option B, here it has given when switch S is on, D1 conducts and both D2 and D3 are reverse pairs. So this is one of the possible answer, whatever we had seen as per the analysis. So here this D1 will be on and D2, D3 will be reverse pairs, that we had seen. So option B is one of the correct answer here. And when switch S is off, then we had seen D1 is reverse pairs and both D2 and D3 will be in the conducting state. It means it will be in the on state. So next possible answer is option C, because this is multiple select question. So more than one option will be the right answer for this question. And by this way, the final answer for this question is option B and C. And this is the end of the explanation for this question. So the question here is, the Zener diode in the circuit has a breakdown voltage of 5 volt full stop. The current gain beta of the transistor in the active region is 99 full stop. Ignore base to emitter voltage drop as a VBE full stop. The current through the 20 ohm of the resistance in milliampere is, and this is given as a fill in the blank. So this is NAT type of the question, and this is the question they had asked in GATE 2023 for electrical branch. So now we can redraw this circuit for better understanding in this fashion, and now I am going to explain how to find out the current passing through this 20 ohm. So if you observe this circuit here, then it is saying that first of all we need to check it about whether this Zener diode is on or not. If Zener diode is on, then whatever current is passing through this as a 7 kilo ohm, this will be dividing into two parts. One will be going through this Zener diode and another one is going through this base of the transistor. And at this point at Vx, whatever current is passing through this as a emitter current, and from this side as a Zener current, whatever it is coming, both will be joining together. And then we need to find out this Vx value, which is called the voltage drop. across this 20 ohm of the resistance, then we can easily find out their current passing through that also. If it is not, if Zener diode is not conducting, it means that the emitter current passing through this 10 ohm, the same current is passing through this 20 ohm of the resistance. So our interest is, first of all, we need to check it whether this Zener diode is off or on. So first of all, we need to assume that this Zener diode is in the off state, and then we need to cross check whether our assumption is correct or not. So if the voltage drop, for example, let's say this node voltage is VB and the another terminal of this Zener diode is Vx, if voltage drop across VB to Vx point, as like I can say it here as a VBx. So if VBx is greater than equal to 5 volt, then only we can say that Zener diode is on, otherwise it will be in the off state. So our interest to find out whether it is on or off, we need to assume this Zener diode initially in the off state, and then we need to find out open circuited voltage as a base voltage and this Vx voltage. Then we can easily find out their difference as a VB minus Vx. So if VBx is greater than equal to Vz, then Zener is on, otherwise off. Zener is on, otherwise it will be off. So now let's say this is open circuited. We are assuming that Zener diode is in the off state, and now we are doing that open circuit analysis. So here if the Zener diode is off, then no current is passing through this Zener diode. So whatever current is coming from this 7 kilo ohm, this is treating here as a base current to this transistor, and if we are able to find out their base current, then we can easily find out their emitter current also, because their beta value of the transistor has given as a 99. So now here, as we know that this emitter current in terms of base current is given as this IE is equal to, this emitter current is equal to 1 plus beta times of IB. And what is the beta value here? It is 99 into IB. So this will become here 100 IB. This will become here as a 100 IB. So this base voltage will be what? This base voltage will become as a 30 into 100 IB, because there is no voltage drop across this VBE. So this base voltage will be what? Voltage drop across this and voltage drop across this, the sum of these two, plus VBE is 0. So that will become here as a base voltage. So this 10 and 20, if Zener diode is assumed as a not conducting, then 10, 20 will be in series. So their sum will become 30 ohm. So 30 into IE. So IE is how much? It is 100 IB. So this we got it here as a base current and the base voltage as a VB. Now we can calculate their base current as a IB. So this base current as a IB is 25 volt as a VCC minus VB divided by 7000 ohm. So now if we'll substitute this here, like 7000 IB is equal to 25 minus this VB is how much? This VB is 30 into 100 IB. So after doing this, we will get it here as a IB is equal to 2.5 milliampere, and this implies that IE is equal to 1 plus beta times of IB. So this will become here as a 250 milliampere. Substitute the value of beta as a 99 and IB as a 2.5 milliampere. So this IE will become 250 milliampere. Now we need to calculate this base voltage as a VB by knowing this IE or IB. So this VB is equal to 25 volt minus 7K into base voltage is how much? 2 point, this base current is how much? 2.5 milliampere. So this is giving here as a VB is equal to 7.5 volt, and Vx is how much? This Vx is nothing but whatever we got emitter current into this resistance. So this is 20 into IE. So this we can write it here, 20 into IE is 250 milliampere. So this will become here as a 5 volt. So now this VBX is how much? This VBX is equal to VB minus Vx. So VB is 7.5 volt and Vx is 5 volt. So we got it here as a 2.5 volt. So this VBX as a 2.5 volt is lesser than as a Vz is equal to 5 volt. So this indicates that we had assumed that Zener diode will be in the off state. So now it is verifying, it is justifying by finding this value as a 2.5 volt. So this indicates that Zener diode is off, Zener is off, and our assumption is correct. If our assumption is correct, then whatever we got the emitter current that is passing through this 10 ohm and 20 ohm, this will be same. So that current passing through this 20 ohm, we got it here as a 250 milliampere. So the emitter current in terms of milliampere is 250 milliampere. And as this question belongs to numerical answer type, so their unit has already mentioned milliampere. So their numerical values will be 250. So the final answer for this question is 250, and by that way this is the end of the solution for this question.